All right. Today we are talking about chapter 22, debugging. Um, this is actually the start of the techniques section, but unlike most of the previous sections, the introduction doesn't really have any content here. It just says, here's what we're going to be looking at in these next few chapters. So I didn't think, thankfully, it didn't because I didn't think of that until after I ran out of time to work on slides. I wasn't going to be doing this chapter, and so I'm mostly prepared. The notes, the slides that existed were pretty comprehensive, although I reworded almost everything to avoid. There was a lot of just copy paste of entire sections of the book, so we're not doing that anymore, thankfully. All right. Uh, so today, overall, what we're trying to do is find and fix errors. This is really well, except for a tiny bit at the end. It's specifically around something is throwing an error. So you're at, like it actually fails to run versus, you could also have errors where it's getting the wrong answer, but it's not throwing any error. Kind of touch on ways to debug that, but not exactly. So we're trying to find and fix errors. We're going to use traceback to locate exactly where an error occurred. Um, we're going to pause the execution of a function and launch an interactive environment to explore what's happening. We're going to do a little bit of talking about how to debug non-interactive code. And then we're going to look at some other things that we can do with debugging. We have a couple quotes. One of them is from the book. Finding your bug is a process of confirming the many things that you believe are true until you find one which is not true. And Hadley quotes Norm Metloff. And then a previous cohort added this other one that debugging is like being the detective in a crime movie where you're also the murderer. Yeah, I like that one. Um, yeah, yeah. I'll just not comment on Sam's comment. All right. Um, So the Hadley points out that the first thing you should do is Google your error message. I think he overstates it a little bit. Like if you know what it means, or you've seen the error message many times, or that kind of thing, it's probably not worth uh, Googling. But if it is something that you're not exactly sure what it means, yeah, Google can be helpful. Um, yeah, and so I'll come back to your comment, Stas. There are these packages. I haven't used these, but they're errorist technically reps searcher, but um, it is a package to basically automatically search Google when you get an error message. Um, I don't know how useful or how like necessary those are anymore, although getting an actual human experience of an error can sometimes be helpful versus generative AI recognizing an error. But it was interesting to know that those exist. I might have to start playing with those. Um, the next thing here, hold on a sec. I want to see. Can't see anybody. Here we go. I didn't have a window where I could see faces, and so I want to be able to see the people who are visible at least. Yeah, in theory. Um, Again, rearranging my windows real quick. Sorry about that. Oh, there we go, though. Okay, there we go. Yeah, so yeah, he talks about like get your bug down to a reprex. There's the reprex package, which is just kind of a way to test that you have all of the information that's necessary for the bug. It will do a little bit of what we talked about at the very end about it's making sure it's running it in like a clean session. Because um, if what you think is part of the bug doesn't include some variable, the reprex won't have that variable, and it will probably get a different error than what you're expecting or that kind of thing. And part of the reason that doing that is really useful is it lets you, like a lot of times I'll be just trying to figure out the way to explain the bug to someone. I take the time to do this, and that causes you to change some variable or change something in your environment or whatever, where you go, oh, that's what the bug was. So either that, or it causes you to like, oh, it only happens when I change this one thing. Oh, it must be that one case in the function or that kind of thing. So just taking the time to make a nice, small, reproducible thing, um, as if you're going to ask someone about it, even if you don't end up asking someone about it, is really useful. Um, and yeah, Google is still also very useful. Oh, and then another reason to get this nice, small, reproducible version, you might have to execute it many times. And so getting it down to, okay, I don't have to have this 10 gig data file. It also works with an empty data frame. I still get the same error, or something like that, where you can make it much faster to repeatedly run and figure out what's going on. He recommends, uh, I guess find bugs isn't necessarily correct here, but like diagnose and repair bugs, using the scientific method. So use the scientific method to find and repair bugs. He says to generate, like actually take the time to think about, okay, what do I think is going wrong? Oh, I've got a typo there, but how could I test that is actually what's going wrong? And I do think it's useful and something I don't always necessarily do cleanly of, record what you have tried. It's so that if you don't fix it, or you end up having to ask someone about it or anything like that, having a record of what you thought it might be, and how you proved it wasn't that, uh, can save people a lot of time. If you're going to go post something on DSLC, telling people what it definitely isn't can be just as useful, because then they don't have to do the same thing. Um, but also just for future you, if you have this list of things that you think it might be, and you can show how it's not these first five, you won't have to repeat those. And having that record also can show you, when you finally find it and you're like, well, I thought I had eliminated that. And you can see, what you had done and why there might have been a flaw in your reasoning. He talks a little bit about how automated testing can help. This isn't really the book to go heavily into it, because our packages talks a lot more about test that. But you know, this is really big to me, of make sure that like the parts of any function that work, that you have a test case that proves that still works, so that when you change it, you can tell easily if it broke. Um, and then, the thing that you're trying to debug, add that as a test case, almost definitely. Like, even if you already have well-tested code, add a test case for this weird one that someone has reported, so it doesn't break again. And then, back on the record your results, if you think, well, okay, I think this might be what's causing it. So if I have this as the input, it should break in the same way. If that doesn't break, log that, and you can just log it as a test. So the next thing is the traceback function. We're going to talk about this a little bit, about how to use that to locate where a test is, or a failure is happening. So we're going to start looking at this series of chained functions. You've got, F calls G, G calls H calls I, and then I finally checks that input, which has been renamed a few times. And I'm going to read Pan's comment in a second, but yeah, this will, take that. It's technically A, but A gets renamed as B, and B gets renamed as C. C gets renamed to D, and then finally D gets checked. And the error message here just says D must be numeric. And then uses it, whatever. And so if you call that with something that's not numeric, then you get the error message. And by default still looks at least pretty much like this, but in our studio, it'll give you a show traceback and a rerun with debug. And before I go on, I want to see what's going on in chat so I don't lose it. Um, yeah, yeah, we had really long thread about the two ways to make a reprex of either start with something complicated and peel things away, or start with like the simplest example you can think of and add things until it breaks. Um, both of those can be really useful. Often you have the this is how it breaks, and so I usually strip things away, but I don't know, sometimes I'll pretty quickly, I guess I go from both sides of what's the simplest thing that does work and then kind of go from there. Looks like you have a question, Nick.
Can I pull people? I'm like trying to get into the ladder where it's kind of add complexity as we go. And then reminds me of like behavior driven development where you have like requirements that you set like in a structured way. And then you make sure your tests fail early. And then you just add the complexity or the functionality that meet the requirements and hopefully your test pass. But I'm often in the place of I don't know what the exact comprehensive like requirements are, so I'm like make it as I go, motivate people. I don't know how they manage that.
I'm sorry, I zoned out for the beginning of your question there. Sorry about that. Or your comment rather.
Yeah, yeah, it was just
Just
about how people like have they tried doing like behavior driven development and where they add that
yes.
functionality complexity early on and how do they manage like requirements that you didn't think of early on or didn't know they exist, but then they say, oh, that is a requirement, as you like develop things over time.
Yes. Like technically that is the difference between a tidyverse pack or rlib or any of those the packages that are below version 1 and version 1 or higher is you're like if it's not version 1 yet we can completely break it and just be aware of that now. Actually, like I think most of their packages are at version 1 or higher now, so there's less risk of that, and they still sometimes break things, but they have the whole lifecycle system to at least let you know. So and that does it relates to Stas's thing of if I am still in the early experimental phase of a package, of a function, I guess, um, I don't feel as bad if I break old things, as long as like I explain why or whatever. But once it's older, try to add any new functionality in a way that doesn't break old functionality. And that's definitely something to, that's a balance to find when you're working on things.
Yeah.
Depends on how much you have to run old things. Um,
Mm.
but if you have a report that's using the function every day, you don't want to break that report. So,
Yeah, yeah, for sure.
all
Yeah.
right. All right. So, this is just, okay, we've gotten the failure. And now we will look at that. We can use traceback, or we can click show traceback, which um, runs traceback, this function. These are all screenshots because he actually talks about it a little bit at the end. This does not work like a couple iterations deep where we're inside of a Quarto doc running the function. Um, but you can do the same idea. Um, so it creates this traceback that from the bottom to the top is what happened. It's the what's called the call stack. Uh, so we called f of a, and that called g of a, which called h of b, called I of c, and then finally we get this error triggered. Um, in our studio, if there is a file associated with this, these will be. Actually, I'm not sure if they're clickable links by default. I think they are. Um, There is a function, rline global handle, which I'm going to talk about a little bit more because it replaces some of what he talks about in the book, which makes it's funny. It mostly makes your error messaging prettier, but there's some things that I'm not loving about it right now, and I might try working without it for a while. So I haven't had the default view in a little bit. I've been using that rline global handle. It'll be on screen in case you can't understand what I'm saying in a minute. Um, yeah. So I think for what Stas is talking about, we'll talk about that in a little bit. All right, which might be yeah, it's basically it's not the next slide, but slide after that. So it, related to that, that traceback can get really confusing because of the way R handles things. That even in this basic one, like F doesn't have any problem with A, and then G doesn't have any problem with what it got fed, the variable A, and H doesn't have any problem with variable B. I doesn't have any problem with variable C. But when you get to, well, I guess it was I that eventually, yeah. When you get to I, when it calls is numeric D, that's when or sorry, when you call this stop, uh, that's where you finally get an error. Um, because all these other functions never looked at it. They don't know what it is until it's way up there. And here, if we tack on a function J, which calls K, and then we put J in as the argument, as the argument to F, again, it's not until you get to I that this call gets evaluated. And so it can be a little confusing to find what happened. Now, in this exact case, I should have, if I'd had a little bit more time, I would have made one that branches a bit more because I don't find this that hard to follow. It's just a chain, it's really straightforward. But it's once you call J, that calls K, which causes the error. So um, that can be a little bit um, easier to deal with this rline global handle. You can just call that in your R profile, and it changes the way errors are handled. This is in I'm showing it from Positron, um, which has the AI stuff built into it now too. Um, but so it does make a nice tree like this. Um, I didn't have this saved when I ran it. If it were saved, it would have links just like the normal traceback. So when you have something like that, deeply nested thing, and uh, it's just really hard to keep track of where things are actually happening, this can be really useful. It, I don't know yet. I haven't, I just found that there are some things that it is doing that I didn't realize it was doing. And so I'm going to try going back and forth between using it and not and see what I think because I want to get better at working with the interactive debugger. I do some of this and I'll talk about that, but I don't like it can be easier. Um, so um, I will say right now, I don't know the positron equivalents of these things. There's some like I know how to do some of this in positron, but I don't know all of it. There is a way to do all of this in positron,
Hmm.
and then some. Like you can do more levels of debugging, and you can set up different debuggers and things like that. So, um, but our studio itself, when you get an error message, when you don't have that global trace thing activated, there will be a button or a link that says rerun with debug. Uh, you can also, there's a setting, debug on error, break in code, which just always reruns with debug, basically. So if an error happens, it shows you where that error happened. Um, I say always, it's technically, unless you have set another setting, it only does it for your own code. So if someone else's code breaks, you don't go to the point in their code where it's broken normally. Uh, which there's pros and cons to both of those. You can also in anything um, set use the browser function to set a breakpoint in your code, which will launch the interactive debugger in whatever session you call that code from. The danger of this is you want to make sure not to leave those browsers in there because um, it will go into that interactive mode whenever you call the function, which we'll talk about how you can do these a little bit more safely. But that is really nice. And if you haven't worked with um, any of this debugging stuff, I do recommend playing with it in your own uh, tooling when you're working because um, it's a lot better than just we talk a little bit at the very end about just putting print statements in or that kind of thing, trying to figure out where you are. All right. Something nice about browser is it's a function. So you can make it conditional. You can say, okay, in this case that I think is causing the error. So when B is less than 0, in that case, go into browser, otherwise don't. And so you can use that to uh, set up some of your hypothesis testing like we talked about. Um, and yes, uh,
Hmm.
linting can catch your browser calls. I don't use browser that much. I use um, other ways to stop, and we'll talk about this a little bit. But like the advantage of browser is you can put it like anywhere within the code. But usually, what I would do in that case is, well, if I care about this other route, then I need a subfunction, and so I'll break off that piece into a function, and then you can just debug that function because if you enter that function, you know that you've hit the error condition. So um, I'm very much a fan of small functions with clear names so that you can tell what it's doing and it's easier to remember. That only works really well if you have a way to hop around between definitions of different functions. But F2 in RStudio or I don't remember what it is by default in Positron, but if you use the RStudio bindings, it's a F2. Um, Yeah. So yeah, you can set flags, you can set debug flags in functions or in options. Um, there are ways to do this for sure. Um, the other one, well, let's see. Oh, just to go on a little bit more about browser. You have commands like there's next. That second one is step into S. Uh, and then there's finish F, and then continue and stop. So next just is do the next thing. Depending where you are, enter usually is also next. Um, S is cool, like the this thing here. You can just keep going, like go deeper into the tree of okay, it's not happening in my main function here. I think it's happening in this function that it calls. That can be useful to figure out like why is my function calling or causing some tidyverse function to fail or whatever, because you can just kind of keep going down that chain and figure out exactly where it is. And the important thing about all this is when you're there, you see the function environment the way the function sees everything. So you see what variables it's getting, and as it changes things, your environment contains those versions of those variables. Um, let's see. So that's S. Finish is like whatever piece I'm in, go to the end of that before you begin debugging again. So if you step down into a function, it'll like get back out of that function. Continue is just, okay, I'm done debugging, finish. I've seen what I need to see. Um, yeah, so yeah, Stas said that stepping with S into methods can get really weird because it's hard to see where you are or how you got there sometimes. Um, but you know, it's better than just being totally lost. But yeah, so C will finish or Q stop is like, oh no, never mind. I don't. Um, I, a lot of times if I figure out what the bug is, uh, I will, either C or Q depending on where I am, whether I have to do a whole bunch of things to make it not break, or if I've confirmed that, okay, this fix I did made it not break. Either way, finish it out and then go actually like really fix it. All right. So the other thing for browser is if you're working in RStudio, and this is the one where I'm sure there's a way to do this in Positron, but I just don't normally use Positron yet. Um, you can just click to the left side of a line number and it'll put a little red dot there, or depending on what you're, a colored dot there. Um, and that is the equivalent to there being a call to the function browser at that point in the code. But it's only there for you. Like it's not really in the code. It's just tagged as being in the code. You can also shift F9. I don't think I've ever done that, but good to know. Um, some downsides on that is there are unusual situations which are in their documentation. Actually, I haven't dug into this documentation, but supposedly it's there at least. Of it can fail like this. The breakpoints cannot work how you expect them to work in certain cases. And he pointed out that it can't be conditional, but it depends how much. Like you could write the if. Um, I guess you need something to happen inside of that if, but whatever. You could set things up to make it work if you really want to. But again, you can make it conditional by having a function that gets called in that condition and then putting your breakpoint there. Yeah. So Stas points out that in RStudio, a lot of times, when you're in the debugger, you can run code, so you can like change what's happening in the middle of a function call. And so maybe you'll call the next part of the function before you officially go to it. So you can kind of like, oh, I need to change this input to be positive or to be a character instead of an integer or whatever. Um, and yeah, if you've got a bunch of other calculations before that, you might want to stop while you're there and just like play around with things once you have everything set up. But then you can also, if not, like a good thing to do is put your browser at that point so that you don't have to go through all the stuff before that next time. You can just stop at the point where you're like, oh, this is where the error gets introduced. So you can change that. All right. Um, this one I never use, but it's a thing that you can. Well, I guess I kind of do it just through a setting in RStudio, but you can have it. Um, there's error equals recover, and it will ask you basically where you want to enter the debugging. Um, Again, I haven't played with this pretty much at all. Um, that could be a useful thing to experiment with.
It seems that here, instead of like putting in the browser function like directly, it's if an error occurs, it'll just stop you no matter
Yeah,
haircut, right?
it's more of I don't know that I'm going to have an error. And so like putting this in your R profile so that whenever you run into an error, it will say, okay, you hit an error. What do you want to do about it?
Uh,
Um, and yeah, it depends again. Um, if the traceback is understandable enough that you can tell what the heck it's talking about. So yeah, you could do that, or you can just turn it on when you are
uh,
in debug mode. Like either way.
uh,
Um, and yeah, in these cases where like I know it's happening somewhere in this nested thing. Well, let me see if it's happening here at this deepest level. Run it. Oh no, let's try. Try a different run with recover still on, and it'll go through that and let you try different things. All right. You can use the function debug, which I mean, I guess I kind of knew that what it's doing is virtually inserting browser as the first line of that function. Um, so it's editing the body of the function to just add browser at the top. Um, Otherwise, it acts exactly as if you had done that, except it's only, again, your local version of it. If you restart your session, debug goes away. Um, and so then you undebug to turn it off, or usually what I would do is just Control Shift F10 in RStudio, restart my session because I try to do that often enough that um that I can know that it's not something that I did before that broke things.
Mhm.
There's formally this is debug once, but it's really debugance is the proper pronunciation of that. That's from our studio talk in 2020. Someone pointed that out, and I can't not see it now. It's like Beyonce, debugance. That turns on basically that turns on debug, and then as soon as you call the function, it automatically doesn't undebug to turn debug back off for that function. Um, and yeah, it'll do it once, so that's really useful. And then there's also, and I don't think I've ever used this, but set breakpoint in utils, where you can give it a file name and a line number, and it will set a debug at that point in the file. Um, I suspect it's possible that like test that has some version of this happening in some places. Um, so all right. What else we got? Oh, there are different ways of showing the call stacks. Uh, so yeah, the images are kind of useful for that. Um, traceback is this numbered list like we've been looking at. Um, there's where, which actually I don't think I've ever used, but it shows it kind of like traceback. It's basically the same. Um, recover. Oh, sorry, no, because it's the opposite order. That's right. So everything else, everything other than traceback, um, browsers a little different. But anyway, they're going to show it in the order of the calls. So going forward versus traceback shows it backwards. I think the point of this is try to put like the actual error at the top, like where the error actually happened. But because of lazy evaluation, that might be it might be that the error really happened much before that. It's just that nothing ever really like triggered or made the error real. Um, and yeah, the Erlang stuff does the indentation to make the trees a lot easier to understand. At least that's the idea. I guess before I go on, there's some the rest of this is more weird cases. um, That's, I don't know. Does anyone have anything? Did I miss anything in chat? Let's see. Um, yeah, Shiny. Debugging Shiny is a pain. Um,
Hmm.
if you're working with something like Shiny, that is where I'm a very big fan of break things apart as much as you can, because then at least you'll get a function name that it's happening in, or
Hmm.
depending on how you're calling things. And if you have things broken up enough, like they shouldn't be at some level, you're no longer really reactive. You're just getting a normal variable and you can see what's happening. Um, and yeah, you can use browser to find issues. You can use recover shiny.error equals recover. Stan said so. Shiny is probably the next book that I'm going to do is mastering Shiny. It is a different beast for sure, but it's so some of the things that are confusing about it, some of it is just that it's R6. And so some of this applies if you're working with R6 outside of Shiny, that it can be really confusing where the error is happening because it's some method of some R6 class and yada yada yada. But yeah, we'll see. I don't want to set that too solidly in stone. But I'm probably going to do Shiny, mastering Shiny next. All right. So yeah, going on non-interactive debugging. this it's a very small section. There's the caller function or caller package, which lets you call a function in a fresh R environment. That can be really useful for debugging because it doesn't have any of the random stuff that you have in your environment. And so it might find you or find for you what is going wrong. Um, or help you find. So things that he points out that can cause weirdness that caller can help you or yeah, caller can help you see where it is. Your global environment might have objects that you don't realize are there and are causing problems. You might have um, renamed or you might have a variable that it is secretly accessing deep in some piece of the function. You might have an option set. You might have all kinds of crazy things like that. You might have, and caller doesn't necessarily help with this, but you might have packages available. You might have packages loaded that caller wouldn't have loaded, and that can change the way things work. You might also have packages available that the person reporting the bug doesn't have. Now, you shouldn't run into that if you're working within a package because other checks will specifically tell you that. But if you're not using a package and you're just giving code to someone, you might be making an assumption about what they have available. So that's something to watch out for. You might have objects in your environment that it doesn't, including by default, if an object has a dot at the start of it, it doesn't show up in your RStudio panel. And so if it's, dot name, that's an invisible variable that you might not realize you have. And even when you clear, like I think when you click the broom to clear out all the objects, it'll ask you if you want to get rid of those. It says, also remove hidden objects or something like that. So that can be tricky. I also use that sometimes so that I can have functions that don't clutter my environment, but that I have available to me. So, but yeah, that can be something to look out for. Your working directory could be weird. And so, if you had changed your working directory, it might cause things to be weird. There's path environment variables, rlibs environment variables. Lots of things like that can cause confusing errors. That is something where another one that we have read in the past is what they forgot to teach you about R, also known as this rstats.wtf. Clearly, WTF stands for what they forgot, not anything else you might think it stands for. So that one of the best pieces of advice they have is like Control Shift F10 or Command Shift F10 restarts your R session. Do that like all the time, because that will clear out all those objects that are weird that might cause problems. Now, obviously, if you're working with some giant data set, this can be a pain because even reloading that data set might be slow. But it's, whenever you can, refreshing that your environment can can solve so many problems. Like there have been so many things where I'm like, why is this? I don't understand why this works this way. Oh, right. I used with our 3 hours ago to redefine some function and I forgot I did that. Um, with our you can, well, I guess technically that's in test that you can um, redefine what some function inside of another function, like even though it's defined locally, you can redefine what it means. It can be very confusing if you don't realize that you have done that. So, um, clear those out from time to time. More on that if we ever do or when we do our packages book again. Um, I have never used this, so even more so than the recover. There's dump frames, which probably could be interesting um for some shiny things that you can, but also if you have things that are running on a schedule or whatever. Uh, yeah, I haven't used it at all. And sorry, by the way, these are the slides where um I ran out of time basically, and so I did a little bit of tweaks on them, but I didn't try out the code. It's an interesting idea. I do have some things that run processes for DSLC, and I like manually log some things, but just dumping the whole thing, um, that's an interesting idea. And then it'll let you load that dumped. Wow, yeah, that's neat. So then you can later interactively explore exactly what went wrong. Huh. I really
Interesting.
need to build that into some of my things, I think.
So does our studio like I don't know I don't know how like browser like works, how it like stops you. So does our studio just like keep track of the call stack? And then once you have like dumped out frames, like it'll just like take well, I'm assuming our studio has like access to like a temporary folder, and then like as it runs, it puts its stuff there, but dumped out frames and just like puts portion of that, I guess, into a file.
Um, I don't know. I mean, if this is if this is on, then it would do it for any error, and that error like always in R knows the whole tree that it came from. So it knows everything that it knows its environment. Like that's part of what that dump would contain. So it
Yeah.
wouldn't like well no, it should include anything that is like accessed and available to that function. So that is an interesting one. I have not used this. I've used text reports of what went wrong, but not like you can actually load the session and experience it like your failed function experienced it.
That's super.
Um, that could be interesting. Now, I don't know. I'll have to play around with this, or I might have to play around with this. Um, so yeah, I will come back and read that in a little bit, Stas, because yes, targets is special. All right. So he talks a little bit about print debugging. Like eventually you might get to the point where you're like, I can't figure out why it's going down this route or what is causing this. And so you can just put cat, or if you use the CLI package, you can do fancier, prettier things, but basically you just have it print things as you're going through. This is the like base level, oh God, I just can't figure this out for some shiny thing or something and just make it spew stuff into a log or onto the screen while I'm interacting with the app to see what happens. Um, Sometimes this can be like the best you can, or it's probably not the best you can do, but it might be the fastest that you can do while you're trying to figure out exactly how to approach it. And then uh, both R Markdown and Quarto, um, the first thing to do if you're running into errors and you can't find them, well, number one, um, yeah, call it locally instead of just like um, Control Shift K or whatever to get to the reports more cleanly. That can help. Um, you can use uh, sync, which again, I don't remember exactly what it does, but you can use that to get better output out of, or I think that gets it where you can like actually show the error um, info in the doc when you're rendering your R markdown so that it makes it more useful. Or I guess it's the opposite of that. Just bring it into your session. Um, yeah, it's where you write things. So uh, I remember like that one is one definitely read the help on sync when you're going to use it because it's one that can like badly break things. So you want to be careful about that. Um, and then he doesn't mention, but like whenever you have a code block in our Markdown or Quarto, if you name it, your life is going to be easier when you're trying to debug because instead of just getting, in block number 472, there's an error. If you name it, can know exactly what block it happened in. Now, this is something that I am very much aware of because of the old R Markdown book down slides. You know, there could be something in chapter 27 of a 40 chapter book that fails, and it's just at that point just block number 892, and I have no idea which block is actually failing. And so named blocks can be very useful just when you're looking through the log of what went wrong, trying to see what happened. But again,
Mhm.
our Markdown Quarto are like Shiny to where it can be just confusing of like following the chain of the error back up to, okay, but what actually caused this error? What really happened? Um, yes. All right. Um, Functions can fail sometimes without actually causing an error. And so, if you are, this one, I forget that this is a thing, but if you're getting warnings that you don't expect, a thing you can do is there's this options warning equals two turns warnings into errors. And so you can just make it so that in your current session, anything that throws a warning will actually throw an error. And then if you have your error set up to debug, any warning would send you into the debugger. And so that can be useful. Um, there's a solution in the book for unexpected messages, and that solution no longer actually works because it uses a function that doesn't exist anymore in our line. Um, and again, I didn't have time to dig in and sort out. I um, think there's probably a way in our line to turn even messages into errors, but I can't. I don't know how to do that off the top of my head. Um, he pointed out, and I never think about this, but that if you have a function that just dies, like it's just running and not returning, when you terminate it, you might be able to use traceback and see where it was. Um, like even if it doesn't tell you in an error message, a traceback might still show you where it had gotten in the chain of things. And so that could at least tell you, oh, throw my browser call in this function because that's where it died or something like that. And then when R actually crashes somewhere or another, that means that there's compiled code that choked, um, which, you know, could be like a lot of times that's going to be a bug report or it's going to be, oh, don't call that function in such a stupid way. Like I did something really broken there. Um, and so just knowing that that's pretty certainly what is happening um, can be helpful figuring out what's wrong. Okay. Some useful we do have some useful links in this talk. I didn't change these. That Jenny Bryan had a really great talk uh, back in 2020. Wow. Um, Actually, I'm not sure that might be yeah, I guess that's the right year. Um, Objective type closure is not subsettable. It's about like cryptic error messages and how to deal with them. And um, yes, and yeah, it was San Francisco, the RStudio Conf right before the pandemic. That was what was going on. Why is it was the scary one because it wasn't really before the pandemic. It was before we knew it was a pandemic. Anyway, um, it was a really good talk about like how to actually read error messages. And I will say, like Hadley didn't really say this in the Google it section, but step back, take a breath, and actually read the error message. Sometimes they seem like they make no sense, but it might just be, oh, they're saying it in a weird way. Like really try to figure out what is the error message trying to tell you. And that's objective type closure is not subsettable until you know what they mean, until you know what those words mean. Is like just so weird. Like, what does that mean? But we've talked about, closure is like a function and its environment, and you can't subset the function. So that means that you have a function that you put square brackets on or a dollar sign. You probably thought it was, yeah, filter $A. Like it does have a meaning. It either means that you have a typo bracket where you meant to put a parentheses and you put a square bracket, or you have a dollar sign and you thought it was like df is the one of the classic examples. Like this df is a function. So if you don't actually have a variable called df, then it'll try to load the function df and try to subset it, and that doesn't work. So
Mhm.
or maybe you meant to do uh my fun a, and you did that, things like that. So um learning what these words mean and then actually reading them and paying attention to what their message says sometimes can be useful. It can be hard because sometimes you just get this wall of noise and you're like, what? I don't understand. Um, but yeah, try to read through it. But yeah, her talk has lots of useful things on debugging, including I think it has basically this whole chapter condensed into the talk. What they forgot to teach you about R, specifically the chapter 12 is on debugging, but the whole book is useful and it's really short. So, just like useful. It's not, there might be, it's old-ish. So there might be things in it that aren't true anymore. And a lot of it's specific to our studio. So if you're using Positron, then might not exactly match up, but the kinds of things to look for would still work. And then let's see a 10. We'll wrap up in a minute. But minimal reprex for a Shiny app is there's a video by Hadley. I think this was probably it's around the time that Mastering Shiny came out, or while he was working on my Mastering Shiny or something. Um, that is a useful talk and is a useful chapter within this Mastering Shiny, just in general, because it talks about how to approach making making something minimal, which also can lead to finding the bugs in something. So, and that is the end of our slide deck. So, any other thoughts? I'm gonna have to hop pretty quick here myself, but anything else? Okay, well, I will see you all next week, and we will talk about measuring performance, which is like a lot of times um, it's not really debugging, but I'll try to optimize something, and then I don't first do the measuring thing. So you optimize the thing that actually is super fast and it's not the slow step and it doesn't do anything. So we're going to talk next week about how to measure where things are slow so that you're not wasting time optimizing
Mhm.
things that aren't still slow. All right. I will see you on Slack.